If I have a job that pays me $10 per hour, the amount of money I earn, my salary, will depend on the number of hours that I work. We can graph this situation. Here on the horizontal axis, we have time in hours. And here on the vertical axis, we have salary in dollars. If I work 3 hours, I will earn $30. If I work 6 hours, I will earn $60. And if I work 7 hours, I will earn $70. This allows us to graph the situation. So that we can see that the variable, salary in dollars, changes as we make changes to this other variable, time in hours. The salary is the dependent variable in this case, and the time is the independent variable, because the salary depends on the amount of time worked. When we do science experiments, we very often are measuring the dependent variable while we are controlling the independent variable. In the case of a can like this, we avoid putting it near heat because as the heat increases, the pressure inside the can also increases. If you put this near a heat source, it becomes very dangerous. The can could end up exploding. In a science experiment, we will not experiment with this can. But we could create a science experiment where we control the temperature, the independent variable, while measuring the pressure. The pressure would be the dependent variable because it would depend on the temperature, the independent variable. Here's a question. What are the dependent and independent variables in this situation? We will measure the height of plants while changing the amount of water that the plants are given. What is the dependent variable in this situation? The dependent variable in this situation is the height of plants. And therefore, the independent variable is the amount of water that they are given. We can control the amount of water we give to the plants, and then we can see the effect this has on the height that the plants reach. Here's another question. In this scenario, what is the dependent variable and what is the independent variable? When we charge admission to a club, how many customers do we need in order to make a profit? Which is the dependent variable? The dependent variable is the amount of profit. The independent variable is the number of customers. The amount of profit depends on the number of customers who enter the club and pay the admission. The examples we have looked at so far are all directly proportional situations. As you increase one variable, it causes an increase in another variable. The dependent variable increases as the independent variable is increased. But there are also inversely proportional situations. And we're going to see how this affects our concept of dependent versus independent variables. I drive to a friend's house on a regular basis, and the distance to that friend's house is 200 kilometers. That's a fixed distance. We are not changing the distance. I want to see how my speed affects the trip time. So I have put speed on the horizontal axis. This is my independent variable. I have put trip time on the vertical axis as my dependent variable. If I have to go 200 kilometers at 25 kilometers per hour, it's going to take me 8 hours to do the trip. If I'm going 50 kilometers an hour instead, though, it will take me 4 hours to cover 200 kilometers. And if I'm able to go 100 kilometers per hour, it will take me only 2 hours to do the trip. And what we're seeing here is a different shape, a curve, that represents this inversely proportional situation. What does not change here is the concept of dependent versus independent variables. The dependent variable is still here on the vertical axis, and the independent variable is still here on the horizontal axis. The difference is in the shape of the curve. It goes down instead of climbing up. The dependent variable time in hours depends on the independent variable speed in kilometers per hour. So inversely proportional situations still have a dependent and an independent variable. In this question, we have several hoses of different radii. How long will it take to empty our swimming pool? What is the dependent variable in this situation? The dependent variable is the amount of time it takes to empty the pool. The independent variable is the size of the radius of the hose. The amount of time it takes to empty the pool will depend on how big a hose we use.